SpaceX has now spent more than $15 billion developing Starship, and that number is climbing by approximately $2 billion per year. To put that in perspective, that's more than the entire development cost of the Boeing 747 adjusted for inflation. It's more than NASA spent building the space shuttle, and it's roughly equivalent to what the United States government invested in the Manhattan Project to develop the atomic bomb. Elon Musk is betting a staggering amount of money on a single idea: that rockets can operate like airplanes, launching multiple times per day with minimal refurbishment between flights. The question isn't whether that's technically possible. The question is whether it's economically viable before SpaceX runs out of cash. The $15 billion figure comes from internal financial documents that were leaked to several aerospace publications in late January 2026. These documents break down SpaceX's spending across multiple categories, and the numbers are genuinely shocking. Approximately $4.2 billion has gone into engine development, specifically the Raptor and Raptor 3 variants. That includes building test facilities, manufacturing tooling, materials research, and the cost of engines that exploded during testing. Another $3.8 billion went into constructing the Starbase facility in Texas, including the launch pad, integration towers, propellant storage tanks, and the massive Mechazilla catch system. Then there's $2.6 billion for the Star Factory manufacturing facility in Boca Chica, which is designed to mass-produce Starship vehicles at a rate SpaceX claims will eventually reach one complete rocket per week. An additional $1.9 billion was spent on regulatory compliance, environmental reviews, and legal fees fighting with the Federal Aviation Administration over launch licenses. Infrastructure at Cape Canaveral in Florida consumed another $1.4 billion, covering modifications to Launch Complex 39A and construction of entirely new facilities at Space Launch Complex 37. The remaining $1.1 billion is scattered across dozens of smaller expenses: payroll for thousands of engineers, materials costs, propellant for testing, insurance, and the inevitable cost overruns that plague any development program this ambitious. What makes this spending especially aggressive is the timeline. SpaceX didn't spread these costs over decades like NASA does with programs like the Space Launch System. They've compressed $15 billion in spending into roughly 5 years, from 2021, when Starship development really accelerated, through early 2026. That's an average burn rate of $3 billion per year, though the spending has increased dramatically in recent months. In the fourth quarter of 2025 alone, SpaceX reportedly spent $1.8 billion on Starship-related activities, suggesting they're now burning through roughly $7 billion per year on this program. Where is all that money coming from? SpaceX is a private company, so they don't publish financial statements, but we can piece together the funding sources from various disclosures. The company generates substantial revenue from Falcon 9 launches, estimated at around $4 billion annually. Starlink, their satellite internet business, is bringing in approximately $6 billion per year and growing rapidly. NASA contracts for crew and cargo missions to the International Space Station contribute another $2 billion. That gives SpaceX total annual revenue somewhere in the range of $12 to $14 billion. But revenue isn't profit. SpaceX has operating costs that consume most of that income. Falcon 9 launches aren't free to conduct, even with reusable boosters. Starlink requires constant satellite production and launches to maintain and expand the constellation. The ISS contracts have their own associated costs. Industry analysts estimate SpaceX's operating profit, the actual cash they have left over after covering expenses, is probably around $3 to $4 billion per year. That means they're spending nearly twice their annual profit on Starship development alone. The difference is being covered by outside investment. SpaceX has raised approximately $9 billion in funding rounds since 2022, mostly from venture capital firms and strategic investors betting on the long-term potential of reusable rockets and Mars colonization. But that well isn't infinite. Investors expect returns, and they're starting to ask hard questions about when Starship will transition from a cost center to a revenue generator. Right now, Starship has generated exactly $0 in commercial income. Every launch has been a test flight burning through propellant and hardware without producing any return on investment. This is where the airline analogy becomes critical. Elon Musk has repeatedly stated that his goal is to operate Starship like an airline operates a 737. The plane lands, gets refueled and cleaned, and flies again a few hours later. Do that multiple times per day, every day, and the per-flight cost drops to almost nothing because you're amortizing the development costs across thousands of flights. In theory, this works perfectly. In practice, nobody has ever achieved anything close to that cadence with a rocket. The current record for rocket reusability is held by SpaceX's own Falcon 9, with individual boosters flying up to 23 times before retirement. But even at that impressive reuse rate, Falcon 9 boosters require significant refurbishment between flights. Each booster comes back to the factory for inspection, replacement of heat-stressed components, and testing before it flies again. The turnaround time is measured in weeks or months, not hours. And Falcon 9 is a relatively simple vehicle compared to Starship. It has 9 engines on the first stage. Starship has 33 engines on the booster and 6 more on the upper stage. That's 39 rocket engines that all need to work perfectly, repeatedly, with minimal maintenance. The engines are actually the biggest technical challenge to airline-like operations. The Raptor engines run on liquid methane and liquid oxygen at extreme pressures and temperatures. During a typical flight, the combustion chamber reaches approximately 3,500 degrees Celsius, hot enough to melt most metals. The turbopumps spin at 80,000 revolutions per minute, generating forces that would tear apart conventional machinery. And the engines need to throttle across a huge range, from 40% power up to 100% and back down again, sometimes multiple times during a single flight. Every one of those thermal cycles causes metal fatigue, and eventually something breaks. SpaceX's solution is to design the engines for rapid replacement. Instead of refurbishing engines between flights, they want to simply swap out the entire engine module if anything looks questionable, bolt off the suspect engine, bolt on a fresh one, and launch again. This is exactly how commercial aviation works. When a jet engine reaches its service interval, the airline doesn't disassemble and rebuild it on the wing. They swap it for a refurbished engine and send the old one back to the depot. But jet engines cost about $10 million each. Raptor engines currently cost somewhere around $2 million to manufacture, and SpaceX needs 39 of them per Starship stack. That's $78 million in engines alone. And if you're swapping them out frequently, you need a massive inventory of spare engines constantly being built and refurbished. Then there's the question of launch infrastructure. Airlines can operate their high-frequency model because there are thousands of airports around the world. You can fly a 737 from New York to Los Angeles, turn it around, and fly it back because both cities have suitable airports. Starship, on the other hand, can only launch from 2 locations right now, Starbase in Texas and eventually Cape Canaveral in Florida. SpaceX is building additional launch pads, with sites proposed in California and potentially international locations, but each pad costs upward of $500 million and takes years to construct. You can't achieve airline-like frequency if you only have 2 runways. The regulatory environment is another massive obstacle. The FAA currently treats every Starship launch as a unique event, requiring individual environmental reviews and safety assessments. Getting approval for a single launch can take months of paperwork and coordination. Airlines don't operate that way. They file a flight plan, get clearance from air traffic control, and take off. SpaceX needs the regulatory framework to evolve from treating rockets like experimental vehicles to treating them like transportation infrastructure. That's a political and bureaucratic challenge that probably can't be solved with engineering or money.
But despite all these challenges, there are signs that SpaceX is actually making progress toward their goal. They've now completed 22 Starship test flights, with the most recent missions demonstrating booster catch capabilities and successful ocean splashdowns of the upper stage. The turnaround time between flights has decreased from months to weeks. They're producing new vehicles faster than they're destroying them in tests, which means the inventory of flight-ready hardware is actually growing. And critically, they're learning. Every flight generates terabytes of data about how the vehicle performs, where it fails, and what needs to be improved.
The financial pressure is also forcing innovation. Because SpaceX can't afford to keep spending $7 billion per year indefinitely, they're finding ways to cut costs without sacrificing capability. The new Star Factory uses automation and modular construction techniques to reduce labor costs. The Raptor 3 engine is simpler and cheaper to build than the original Raptor design. They're sourcing materials from multiple suppliers to drive down prices through competition. These are exactly the kinds of incremental improvements that eventually lead to dramatic cost reductions. So, here's the theory that's emerging among industry observers. SpaceX might not achieve true airline-like operations with Starship in the next few years, but they don't need to. What they need is to get the cost per launch down to the point where commercial customers, satellite operators, NASA, maybe even space tourism companies are willing to book flights. If SpaceX can launch Starship for $50 million per flight and charge customers $80 million, suddenly the economics start working. They're generating $30 million in profit per launch, which, at even a modest cadence of one launch per month, that's $360 million in annual profit that can fund further development. The real test comes in late 2026 and into 2027. That's when SpaceX plans to transition from test flights to operational missions. The first commercial Starlink launches on Starship are scheduled for the second half of 2026. NASA's lunar lander contract requires demonstration flights in 2027. If those missions go well, if the vehicles perform reliably and the costs stay under control, then the $15 billion investment starts to look brilliant. But if the technical challenges prove insurmountable, if the regulatory barriers can't be overcome, if the costs keep climbing faster than revenue grows, then this becomes one of the most expensive failures in aerospace history. We're probably going to find out which path we're on very soon. Unfortunately, though, there will probably still be a lot of exploding rockets along the way.